Go ahead. Try it right now. Reach under your arm and attempt to tickle yourself. I'll wait. You can't do it, can you? Your fingers are touching the exact same spot that would send you into uncontrollable laughter if someone else touched it, but your own touch produces almost nothing. This strange limitation reveals something remarkable about how your brain constructs your experience of reality. This isn't just a quirky fact. The reason you cannot tickle yourself opens a window into one of your brain's most sophisticated systems, a prediction machine so powerful it literally rewrites your sensory experience before you're even aware of it. Understanding this mechanism explains everything from why you can't tickle yourself to why some people hear voices, why we feel phantom phone vibrations, and how we distinguish ourselves from the world around us. Let's start with what tickling actually is. When someone runs their fingers along your ribs, two things happen simultaneously. First, sensory neurons in your skin detect the touch and send signals to your somatosensory cortex, registering the physical sensation. Second, a separate system involving the anterior cingulate cortex evaluates the emotional context. Is this threatening? Playful? These regions decide whether the touch should feel pleasurable, alarming, or overwhelmingly ticklish. The tickle response exists at a strange intersection between pleasure and pain. If you've ever been tickled against your will, you know that laughter doesn't necessarily mean enjoyment. Ticklish laughter is involuntary, a reflex that bypasses conscious control. The brain regions that process tickling sit close to areas that process pain and panic, which might explain why prolonged tickling can become genuinely unpleasant. Historical records show tickling was used as punishment and torture in ancient China, and Rome victims would laugh uncontrollably while experiencing genuine distress. But here's where things get interesting. When you try to tickle yourself, both systems are active, but something crucial has changed. Your brain knows it's coming. The moment you decide to move your hand toward your ribs, a cascade of neural activity begins that fundamentally alters how your brain processes the sensation. The key player is your cerebellum, that cauliflower-shaped structure tucked underneath the back of your brain. For centuries, scientists thought it only coordinated movement. Its name literally means little brain in Latin. But we now know the cerebellum is also your brain's prediction engine. Before any voluntary movement, your cerebellum generates a precise prediction of exactly what that movement will feel like. Think about picking up a cup. Your brain needs to know how much force to apply and what the handle will feel like. It can't wait for actual sensory feedback because that takes too long. Instead, your cerebellum creates what neuroscientists call an efference copy, a detailed forecast of the sensory consequences of your action. This prediction arrives at your somatosensory cortex at almost the same time as motor commands reach your muscles. When actual sensory signals arrive from your skin, your brain compares them to the prediction. If they match, the sensation is attenuated, deliberately dialed down. Your brain essentially says, "We expected this, nothing to see here." But if the input doesn't match, the full sensation rushes through unfiltered. This is why dropping your phone feels alarming, or why a sudden tap on your shoulder makes you jump. This system exists for good reason. Imagine if you couldn't distinguish between sensations you created and those from the external world. Every time you moved your arm, the feeling against your body would demand attention. Every time you spoke, your own voice would startle you. The prediction system that prevents self-tickling is the same system allowing you to function as a coherent agent in the world. When you try to tickle yourself, your cerebellum predicts exactly where your fingers will land and how much pressure they'll apply. Because your brain generates this prediction, the sensory input is classified as self-generated and massively reduced. You literally cannot surprise yourself. The tickle response requires surprise, unpredictability, and the sense that something external is acting on you. Here's something fascinating. This explains why certain mental illnesses involve problems with self-monitoring. Research shows that some people with schizophrenia actually can tickle themselves. Their prediction systems appear less effective at distinguishing between self-generated and external sensations. When the boundary between me and not me blurs, the brain can't properly filter out self-generated sensations. This same mechanism might contribute to hallucinations, where internal thoughts are misattributed to external voices. Not all tickling is created equal. Scientists distinguish between two types. The first, Knismesis, is that light, feather-like sensation that makes you want to scratch. It's annoying rather than pleasure-inducing, and doesn't produce laughter. You can actually experience this on yourself. Try lightly running your fingernail across your palm. You'll feel it, but it's not the same as someone else doing it. The second type, Gargalesis, is the heavy, pressure-based tickling that produces uncontrollable laughter, concentrated in your most vulnerable areas: armpits, ribs, neck, and groin. This is what you absolutely cannot reproduce on yourself, and it seems to serve an important evolutionary purpose. Why are our most vulnerable body parts also the most ticklish? The answer might lie in how humans learn to protect themselves. Areas containing major arteries and vital organs trigger the most intense tickle response. This might have served as a training mechanism when children are playfully tickled by parents or siblings. They instinctively learn to protect these vulnerable areas, developing defensive reflexes that could save their lives. During a tickle fight, the ticklish person squirms, twists, and throws their arms up protectively. These are exactly the movements you'd make if someone were genuinely attacking your vulnerable areas. The playfighting of childhood, facilitated by tickling, might prepare children for real conflicts. The laughter signals play, not combat, while training crucial defensive skills. There's also a compelling social component. The areas where we're most ticklish are areas we only allow trusted individuals to access. Being willing to tickle someone signals intimacy and trust. This explains why tickling is common between parents and children, romantic partners, and close friends. It's a way of practicing vulnerability safely. The laughter reinforces social bonds, releasing endorphins and creating positive associations. The age at which tickling emerges is telling. By around 6 months, babies begin to laugh when tickled. Roughly the same time they start developing the cognitive distinction between their own body and the external world. Ticklishness tracks perfectly with development of neural systems that distinguish self from other. Not everyone is equally ticklish. About 5% of people claim they're not ticklish at all, while others are so ticklish that even the threat of tickling makes them react. People frequently tickled as children often become less ticklish as adults, possibly because they've learned to better predict and control the experience. The predictability requirement explains something else. It's almost impossible to tickle the same person the same way twice in rapid succession. After being tickled, people become temporarily less sensitive in that area. Their brain has updated its predictions. What was unexpected has now been incorporated, and the element of surprise is gone. Effective tickling requires variety, constantly changing locations, pressure, and timing. Here's a deeper insight most people never consider. The inability to tickle yourself is evidence of something profound about consciousness itself. Your brain constantly constructs your experience of reality by making predictions and then editing raw sensory data to match. What you experience isn't the world as it actually is, but your brain's best guess about what the world is. When you touch your own arm, you're experiencing not raw sensation, but sensation after your brain has filtered it based on expectation. This predictive processing model has revolutionized neuroscience. It suggests perception isn't a bottom-up process where sensory information flows into consciousness. Instead, it's top-down. Your brain constantly generates predictions and only updates them when predictions are wrong. You can't tickle yourself because your predictions are too good. Your brain's model of your own body is so accurate there's no prediction error to generate the tickle response. So, what does this mean for your daily life? Understanding why you can't tickle yourself gives you a window into how your brain creates your sense of being you. That seamless sense of self, that clear distinction between your actions and the world's actions, is a sophisticated neural achievement requiring constant computational work. It can be disrupted by disease, development, or even just someone else's gentle touch. The next time someone tickles you and you dissolve into helpless laughter, remember that what you're experiencing is your brain's surprise at an unexpected touch. It's momentary confusion about whether this sensation is self or other, and an ancient training mechanism teaching you to protect your most vulnerable parts. You're experiencing the boundary where your self ends and the world begins, drawn not in ink but in the electrical signals of your own nervous system. And if you want something truly strange, try this experiment. Close your eyes and have someone touch your nose while you simultaneously touch your own nose. In some people, this creates a bizarre sensation where their nose seems to disappear or feel longer. The competing sensory predictions create a momentary glitch in your brain's model of your own body. It's called the Pinocchio illusion, and it reveals just how fragile your sense of embodiment really is. You can't tickle yourself because your brain is too good at knowing what you're about to do, and honestly, that's probably for the best. A world where you could accidentally tickle yourself while putting on a shirt would be completely chaotic.